Most chemical reactions used for the production of heat are combustion reactions. The energy released when 1 gram of a substance is combusted is the fuel value of the substance. The fuel value of any food or fuel can be measured by calorimetry. Most of the energy our bodies need comes from carbohydrates and fats. The carbohydrates, known as starches, are decomposed in the intestines into glucose, which is soluble in the blood and is known as blood sugar. It's transported by the blood to cells where it reacts with oxygen in a series of steps, eventually producing carbon dioxide and water and energy. Because carbohydrates break down rapidly, their energy is quickly supplied to the body. However, the body stores only a very small amount of carbohydrates. The average fuel value of a carbohydrate is 17 kilojoules per gram, or 4 kcal per gram. Like carbohydrates, fats produce carbon dioxide and water when metabolized. The body uses the chemical energy from foods to maintain body temperature, to contract muscles, and to construct and repair tissues. Any excess energy is stored as fats. Fats are well suited to serve as the body's energy reserve for at least 2 reasons. 1, they are insoluble in water, which facilitates storage in the body. And 2, they produce more energy per gram than either proteins or carbohydrates, which makes them efficient energy sources on a mass basis. The average fuel value of fats is 38 kilojoules per gram, or 9 kcal per gram. The combustion of carbohydrates and fats in a bomb calorimeter gives the same products as when they are metabolized in the body. The metabolism of proteins produces less energy than combustion in a calorimeter because the products are different. Proteins contain nitrogen, which is released in the bomb calorimeter as N2. In the body, this nitrogen ends up mainly as urea. Proteins are used by the body mainly as building materials for organ walls, skin, hair, muscle, and so forth. On the average, the metabolism of protein produces 17 kilojoules per gram, or 4 kcal per gram, the same as for carbohydrates. We can look at table 5.4 to see some fuel values for some common foods that you might be familiar with. Energy and fuels. The vast majority of energy consumed in this country comes from fossil fuels. During the complete combustion of fuels, carbon is converted into carbon dioxide and hydrogen is converted into water, both of which have large negative enthalpies of formation. Consequently, the greater the percentage of carbon and hydrogen in a fuel, the higher its fuel value. If we look at table 5.5 for comparison, looking at bituminous coal and wood, the coal has a higher fuel value because of its greater carbon content. Sample exercise 513, comparing fuel values. A plant such as celery contains carbohydrates in the form of starch and cellulose. These 2 kinds of carbohydrates have essentially the same fuel value when combusted in a bomb calorimeter. When we consume celery, however, our bodies receive fuel from the starch only. What can we conclude about the difference between starch and cellulose as foods? If cellulose does not provide fuel value, we must conclude that it is not converted in the body to carbon dioxide and water as starch is. A slight but critical difference in the structures of starch and cellulose explains why only starch is broken down into glucose in the body. Cellulose passes through without undergoing significant chemical change. It serves as fiber or roughage in the diet, but provides no caloric value. The nutritional label on a bottle of canola oil indicates that 10 grams of the oil has an energy value of 86 kcal. A similar label on a bottle of pancake syrup indicates that 60 milliliters, about 60 grams, has an energy value of 200 kcal. Account for the difference. The oil has a fuel value of 8.6 kcal per gram, whereas the syrup has a fuel value of about 3.3 kcal per gram. The higher fuel value for the canola oil arises because the oil is essentially pure fat, whereas the syrup is a solution of sugars in water. The oil has a higher fuel value per gram. In addition, the syrup is also diluted by water. Estimating the fuel value of a food from its composition. A 28-gram, 1-ounce serving of a popular breakfast cereal served with 120 milliliters of skim milk provides 8 grams of protein, 26 grams of carbohydrates, and 2 grams of fat. Using the average fuel values of these kinds of substances, estimate the energy value or caloric content of this serving. Also, a person of average weight uses about 100 calories per mile when running or jogging. How many servings of this cereal provide the energy value requirements for running 3 miles? The energy value of the serving will be the sum of the energy values of the protein, carbohydrates, and fat. We are given the masses of the protein, carbohydrates, and fat contained in the combined cereal. We can use the data from table 5.4 to convert these masses to their energy values, which we can then sum to get the total energy value. So we're given the fact that there's 8 grams of protein, and looking at table 5.4, we see that 17 kilojoules per gram of protein is the estimated fuel value. We have 26 grams of carbohydrates in our cereal, and the fuel value for a carbohydrate is 17 kilojoules per gram. And we have 2 grams of fat, which has a fuel value of 38 kilojoules per gram. So adding these up, we come to an answer, 650 kilojoules, and this corresponds to 160 kcal. The conversion is 650 kilojoules, where 4.18 kilojoules is equal to 1 kcal. So this is 160 kcal. Recall that the dietary calorie is the equivalent to 1 kcal. So if your food says that there's 50 calories, then that would be 50 kcal. Thus, the serving provides 160 calories. Here we are faced with a reverse problem. In the second question, we are to calculate the quantity of food that provides a specific energy value. The problem statement provides a conversion factor between calories and miles. The answer to part A provides us with a conversion factor between servings and calories. We can use these two factors in a straightforward dimensional analysis to determine the number of servings needed, rounded to the nearest whole number. So the person is going to run 3 miles. We were told that they are going to burn 100 calories per mile. And we also calculated in part A that 1 serving is 160 calories. Therefore, this person will require 2 servings of the cereal. For practice, dried red beans contain 62% carbohydrate, 22% protein, and 1.5% fat. Estimate the fuel value of these beans. During a very light activity, such as reading or watching television, the average adult uses about 7 kilojoules per minute. How many minutes of such activity can be sustained by the energy provided by a serving of chicken noodle soup containing 13 grams of protein, 15 grams of carbohydrate, and 5 grams of fat?